Welcome back. Let's examine the pricing and valuation considerations for forward rate agreements, which are essentially forward rate contracts with interest rates as underlying. Let's jump right in. Thus far, our discussion on futures and forwards are centered on tangible elements like equities and fixed income instruments. Let's now learn how non-tangible elements like interest rate can be an underlying. One common type of interest rate derivative is a forward rate agreement. LIBOR rates have thus far been the underlying benchmark rate for most FRAs. LIBOR is quoted as an annualized rate based on a 360-day year, and loans based on LIBOR have simple interest calculated on an add-on basis and paid at the expiry of the loan. For example, if the 90-day USD LIBOR is currently quoted at 3%, a 90-day risk-free loan that commences this instance should pay an unannualized interest of 0.75% at the end of 90 days. If the loan principal is $100,000, the borrower has to pay an interest of $750 at the end of the 90 days, along with the principal repayment. You should be aware that the LIBOR rate has already been replaced by the secured overnight financing rate as the benchmark for dollar-denominated derivatives and loans. However, the CFA curriculum still continues to reference LIBOR, so we shall use it in our lesson. For most participants, the point of entering into an FRA is to lock in a certain interest rate for borrowing or lending at some future date. For example, Green is a borrower and he anticipates that he'll need to take a $100,000 90-day loan 30 days from now. However, he is concerned that the borrowing rates would have risen by the time he actually takes the loan. What he can do is take the long side of a forward rate agreement and locks in the forward rate with a notional principal of $100,000. By entering this contract, he agrees to be the fixed rate payer. In return, he receives floating rate payments from the short. The short can be a lender or investor who has a sum to lend in the future and wants to lock in the current interest rate. So, for example, Red anticipates that he will receive $100,000 in 30 days and is concerned that the interest rate may fall in the next 30 days. He locks in the same forward rate by taking the short position against Green. By entering the FRA, changes in the interest rates will not affect him. As the short, Red has to pay Green the floating rate at expiration of the contract. So Green and Red enter into a 30-day forward rate agreement with a locked-in forward rate for the 90-day loan on a notional principal of $100,000. Now, there are a number of unique characteristics about FRA that you must be very clear about. First and foremost, the loan commences at the expiry of the FRA contract, so the 90-day loan starts here and continues until 120 days after the FRA initiation. So actually, the exchange of fixed and floating interest payments should be at the end of the loan. However, the net difference in payments is actually settled in cash at the expiry of the FRA. So this cash settlement is the PV of the net difference in payments. We'll learn how to calculate this later. As with forward contracts, no payment is made at initiation. Be very clear that the FRA contract only covers this period before the initiation of the loan, so payments must be made here. What either party does after settlement is not within the terms of the contract. As the FRA contract has already been settled, neither party is obligated to enter any loan agreement with each other or to any other parties. FRAs are identified in the form of X by Y, where X denotes the number of months to the expiry of the FRA contract, and Y is the number of months to the end of the loan. So for this case, this is a 1/4 FRA. Now that you are clear on how FRAs work, let's get into the calculations. First, how do we determine this contractual fixed forward rate that both parties can agree to? Recall under fixed income, we learned the no arbitrage relationship that the compound returns of a longer period is equal to the product of compound returns for two shorter periods. For this example, we will have the relationship between 120-day LIBOR, 30-day LIBOR, and this forward rate in what we wish to determine. However, since LIBOR assumes simple interest, we do not compound, but adjust the rates directly according to the length of time. And there we have it. We have the relationship to solve for the forward rate. So let's say the 30-day LIBOR is 2.5% and 120-day LIBOR is 3.5%. Solve for the forward rate, you should get 3.82%. Be very clear that this is an annualized rate. This forward rate is stated in the contract as the price of the FRA. We say that the two parties have agreed to enter a 1/4 FRA contract at a price of 3.82%. This means that at initiation, the long expects to pay an effective annualized interest rate of 3.82% for the 90-day loan that commences in 30 days, while the short expects to lend at an effective annualized interest rate of 3.82%. So, let's say at expiration of the FRA, the 90-day LIBOR is 4%. higher than the 3.82% rate that was expected. Based on the current LIBOR rate, the long would need to pay 4% interest if he takes a loan at current rates, while the short will receive 4% interest rate if he lends. In this case, the short should pay the difference in cash, such that he effectively receives the contractual rate of 3.82% and the long pays 3.82%. This rate is the difference between the spot rate and the forward price of the contract. You should find this somewhat familiar, as this is how we calculate the payoff or value of the contract to the long at expiration. To calculate the actual amount, the interest rate should first be adjusted for the length of the loan times the notional principal. Make the calculations, we get $45. This should be the excess amount of interest that the short must pay the long at the end of the loan. Again, we have to emphasize that the FRA contract ends here, and neither party is obligated to enter a loan, so settlement has to be at the expiry of the FRA. So if we're settling at expiry, we should discount this payment to the present value. Using the 4% LIBOR rate as the discount rate for 90 days, we get a present value of $44.55. At settlement, the long should pay the short this amount. Now, here comes the hardest part of this lesson. How do we value the FRA before expiry? Like for equity and fixed income forwards that we learned earlier, the first step is to determine the price of a new contract with the same expiration date loan tenure if initiated at this point. And based on this price, calculate the difference in interest to be paid by the long against the original price. Lastly, discount this amount to its present value. So let's say 20 days after initiation, the 90-day LIBOR is quoted at 4%. What would be the value to the long? To calculate the price of a new contract at this point, we first need the 100-day LIBOR and the 10-day LIBOR. Let's say 100-day LIBOR is 4.2% and 10-day LIBOR is 3.2%. What would be the forward rate for the loan at this point? You may want to take this as a practice from what we've learned earlier. Well, you shouldn't find this too hard. The price of the new contract should be 4.31%. This price is higher than the original contract price of 3.82%. In this case, we have the long paying more interest than what is contracted, so the short has to compensate the long. This works out to $122.50. Lastly, we discount this amount to its present value using the 100-day LIBOR. This is the value to the long at this instance. So, as you can see, an FRA is basically a forward contract with the underlying as interest rate. When interest rate increases, the value to the long increases. Let's conclude with an exercise. A 3x7 FRA was initiated between two parties. Given the following LIBOR rates, what is the appropriate price for the FRA? Pause the video now and work out your answer. And we're back. As with most derivative problems, you are encouraged to draw a timeline so you're clear of the length of time between key events. For a 3x7 FRA, the FRA will expire in 3 months or 90 days, and the loan will end in 7 months or 210 days. The length of the loan is therefore 120 days. The no arbitrage relationship between the 210-day LIBOR rate, 90-day rate, and the forward rate for the loan should be as such. Solve for the forward rate, we get 3.64%. Continuing with this example, 30 days after the initiation of the FRA, the following LIBOR rates are recorded. What is the value of the FRA to the long at this point? Pause the video now and work out your answer. And we're back. Right now, we're at this point on the timeline. There are 60 days to expiration of the contract and 180 days to the end of the loan. The no arbitrage relationship between the 180-day LIBOR rate, 60-day rate, and forward rate is as such. Solve for the forward rate, we get 3. This is the price of a new FRA contract if initiated at this point based on current rates. The difference in interest at the end of the loan is the increase in interest rate times the notional principal. This works out to minus. This value is negative as the price of the FRA has decreased. The value to the long is therefore the PV of this difference in interest amount. Since we need to discount by 180 days, we should use the 180-day LIBOR rate. The discounted value works out to. This is the value to the long at this point. And that concludes our study on the pricing and valuation of forwards and futures. From the next lesson onwards, we will move on to the pricing and valuation of swaps. See you again.